Hello all, welcome back to the Dynamic Pricing with Hierarchical Regression model part 2. So, using our hierarchical linear model in Bayesian package, you can estimate the account specific coefficient. For example, the first retailer Price Chopper at Albany, New York, the intercept is 10.52, the coefficient corresponding to the display activity is 1.21 and coefficient corresponding to the log price is negative 3.7. So the coefficient corresponding to the price is also known as the price elasticity, and here price elasticity is negative as expected, because if you increase the price little bit, then the volume for the demand will go down, and that negative behavior is getting nicely captured here, and also at a very different uh, at a city level, at retailer level, it is nicely getting captured here. Next, what we want to do is we want to check if for the first retailer, if we drop the price by 5%, then expected increase in volume would be how much. It turns out that expected volume, the increase in the volume would be around 20 to 21%, and with some variation will be there, but on an average you can expect about 21% increase in the volume, and that one of the reason is the price elasticity is very high, negative 3.7. So that is the reason the increase in the volume will be high. As a result, how much this change is going to affect the revenue? So the current revenue you can compute as a $3,759, whereas because of this price cut or the discount you are offering to the customer, the revenue you will see is going up to $4,321, or about $4,320 you can see. So this is one of the thing that is very important. So you can provide a cut or a price discount, but does that mean revenue will go up? Or even if it goes up, by how much it will go up? Not if it does not go up significantly, then does it make sense that you give this price cut to the customer? Now I'm going to discuss how you can implement dynamic pricing with hierarchical regression model. So for that we need this library Bayesian, and you can also use the MCMC pack, and we are going to call the the cheese dataset from here. And if we just print the first 5 rows, this is the dataset that you are seeing. This is a particular week: Los Angeles Lucky, Los Angeles Ralph's. This is the volume that they're being sold. This is the display activity on that particular uh, retailer account, and this was the price that was offered. Okay, now first thing what I'm going to do, I'm going to read the name of the retailers, all these retailers. So these are the retailers that you have in your data set. Okay, these are the retailer that you have, and you can see there is 88 retailers are there. So I'm just writing there are 88 retailers. Here I'm going to define a beta, a matrix, a placeholder with 88 rows and 3 columns. So I remember that I'm going to fit the model that log price is equal to function of intercept plus display activity plus log price. Okay, and first thing I'm going to do is I'm going to run a OLS estimator, and I'm then so this is the, let us run this. Okay, and here is the see for some retailer, the if it is n, the coefficient for if, off price turns out to be na, and we can do some investigation. So what we can do, we can just take the row names as beta ls. We can write it here as the retailer. So if we write that, so now we have the, so there is a retailer Stop and Shop in Hartford City in Connecticut. Their elasticity was, they did not able to estimate. And there is another thing, Stop and Shop, who in Boston. I think there is a naming issue here. I'm sorry about that. There's definitely naming issue. So the elasticity for display activity was not correctly estimated, and some of the places it is very large, 26. So it is not very reliable. If you use ordinary least square method, you will see it is not very reliable. We can avoid this problem, and so here we just take the data about the same size. This is the burn-in, this is the MCMC we are giving, and this is where I'm just from the Bayesian package, our hierarchical linear model, you give the data and give the MCMC, call it, it will run very fast. Within 5 seconds it has given all the things out. And if I just, so this is the beta of retailer estimated using, these are the posterior mean estimate of the specific retailer from using MCMC method on hierarchical regression model. So if I just plot the entire thing, you will see Hartford Stop and Shop. Now previously in OLS method it did not able to estimate it, but now it is being estimated properly. So now all the coefficients are now properly estimated. Alright, so this is one of the advantage that we are seeing, that in Bayesian hierarchical regression model we did able to estimate some of the coefficient or retrieve the value of the coefficients, where simple OLS method did fail completely. So here I am going to plot the so this plot, you will see that this is basically this coefficient, posterior mean of the coefficient of display activity, and this is the least square estimates of the coefficient of display activity. And you can see when you are using least square estimates, some of the estimates are very high and these estimates are unreliable, but when I projected them and these of the estimates are reasonably in the range where you would say that okay, this makes sense. So also just visually we can confirm that it is much better. Next we want to discuss how much drop in the or increase in the volume is expected if unit price is decrease by 5%. Okay, so if I drop the unit price by 5%, how much increase in the volume you would expect? So I take the first retailer, I give the retailer name and number, and then this is the basic retailer summary, and then this particular retailer is spending about sold about 1363 volume on an average. The display activity in that retailer is 0.09, and on an average the price is 2.75. so suppose the current price is 2.758. okay, so the current offer is, the first one is for the intercept. I am keeping the display activity at an average 0.09 and 1.01 log of the 2.758 log current price. Now the 5%, if I offer 5% discount, then alternate price will be 2.62, $2.62, and the alternate offer will be just intercept, display activity, and the log of alternate price. Okay, now I am from the out, this out, remember that you run the Bayesian linear hierarchical model, and this output was generated from the hierarchical linear model. From the output I am extracting the draws related to beta for the retailer number 1, and then I'm taking the average of that, and this is the retailer specific coefficient values, and the volume change I'm just first creating a placeholder, and then I am running the volume change. So how I'm doing it? So I'm taking each iteration, I'm taking the beta draw, multiplying it the current offer, and then I'm taking anti e to the power or anti-log, because price is modeled or volume is modeled as log volume. So I have to take the e to the power log volume and base e. So I have taken volume 1 is corresponding to the current offer and volume 2 is corresponding to the alternate offer. So the volume change will be measured as volume 2 minus volume 1 divided by volume 1 times 100. That will be stored as volume change. So the summary of change that we are seeing is about 21% on an average change that we are seeing. Okay, and histogram of the volume change is there. So somewhere between 15% and 25 or 26.7% change we can expect. If you want, you can even do a 95% Bayesian interval quantile of volume change logs equal to 0.025 comma 0.975, and that will give you, so as I said, that 15.48% and 26.74%. so the volume change, expected volume change with 95% confidence, you can say, is will be within this. Now okay, this is my volume change, but what is the expected revenue and current I can expect out because of this, or additional revenue I can expect because of this price cutter I am offering. So the expected revenue is basically retailer summary volume and retailer's price, current price is, current expected revenue is 3759, and changed expected revenue is about This is the current expected revenue and this is the changed expected revenue. So it will go up to 4,321, 23 around that. So quantile, I can again do a 95% confidence interval for the changed or expected revenue, 0.025 and 0.975. So current expected revenue is 3,759 or 3,760 dollar. You can expect that the revenue will go up to somewhere between $4,124 to $4,527. So this is at least you can expect, and this is like really best you can expect because of the 5% discount that you are offering. So with that I will stop this video. In the next video I will introduce how you can include the hierarchical information about your city, about a region. If you want to offer a price cut at a city level, then how your revenue will be affected. If you want to offer a price cut at a regional level, how your revenue is going to affect. So these things are going to make a huge difference. So these things we are going to discuss in the next video. Thank you very much.